why do we have bad guys? You guys made me think of so many issues. Maybe we should just stop everything we're doing right now from a technology point of view, and let's go solve the psychology, sociology, the human side problems, right? So, and then we could build that beautiful picture that you had for us without having to worry about it. And basically, I work in this organization at Duke called the Emerging Technology Office, and there are 18 of us, and we do a little bit of generation stuff. Mainly, we focus on distribution and then premise. And the distribution part is what will the grid look like in the future? And we're chasing this flow where we see microgrids all over the place. And this is like, it's poaching our business. So we're in business to make money, and also we're, not a lot of money, but we're in business to keep the lights on for everyone. We're a regulated utility for the most part. And we have all this solar coming in, distributed generation, you connect it. It may not be owned by us. This is a real precarious position. It comes in and it goes into place. And how are they managing it? They're managing it with a cloud service, potentially, right? Well, who's verifying what's the regulation on that piece? Whereas we keep all our stuff, we try to keep it air-gapped and whitelisted. So I'm not sure how all that's going to shake out. Last week at an EPRI meeting, the Electric Power Research Institute, we reviewed a project from DARPA that says the whole United States, it's black. Everything's out. How long will it take us to bring everything back? And they're saying that we think we can do it in 7 days, or that's the goal. Can you imagine a city without power for 7 days? We go 2 or 3 days, we have really big problems. 1 day is a problem. So, the talks, it's hard for me as my personality. I'm basically I've been in the industry a while. I'm working in a nice R&D group. I'm essentially a firmware guy. I'm an embedded systems developer in my brain, right? That love Jimi Hendrix and Jack Kerouac, right? And I'm ready just to hit the road, and so it's really difficult for me to go to these doom and gloom scenarios. I know we need to do the planning and all that kind of stuff, but I find it very hard sometimes.
It's just your imagination.
It's not leadership. Well, you have to think about the doom and gloom in order to be a leader. Okay, so real quick. So with ABB, I traveled the world a lot. In Hefei, I spent a lot of time in a Chinese city called Hefei. And it's a small Chinese city, 5 million people all packed in there. So when you say 25 million, you go to Shanghai and you see 300 skyscrapers. So the presentation I'm getting ready to tell you is small on the scale of what you described there. Back to the MIT thing. How come you didn't talk about the concept of taking Boston? This is an MIT study that I read. The city of Boston chopped up into 26 pieces where each one is a microgrid, trying to strive to resiliency so that if you lose one, then everybody just keeps happy, So I expected you to speak about that one. The professor from MIT, who I've forgotten his name. Oh well, let's not worry about that one. Okay, so a couple of comments. These are just random thoughts that popped up during those things. With great connectivity comes great responsibility. I think we need to remember that one. When I look at the products that I've worked on in my life, meters and reclosers and cap bank controllers and all these things, whenever a customer asks us for a new requirement, which would typically be the utility or a muni or a co-op, we buried those requirements inside of the product and we created complex, simple devices. They're simple devices. They measure voltage and current, they multiply the two together, they create watts. They keep time. That's what they really do. And in the end, we created 1,000 data element devices. So we added all this complexity over time. So I think one of the questions I'm being asked, what I hear here from a cyber point of view, is how do we go back to simplicity and still stay digital? I think it's impossible to go back to an analog world. I'm not sure how we would do that. I hear calls for that every now and then, but I'm not sure we can put all these people in substations and manage substations, and I'm not sure we can reproduce all this analog gear that would be required to do that. I saw it all. I'm part of the revolution that took it from analog to digital. That's what my life has really been about, that and outsourcing, right? All through the 1980s. I probably shouldn't say stuff like that.
David, can you tolerate an interjection?
Yeah, sure, please.
All right.
Yeah. I like this free-for-all style.
And this may be wrong, but let me try it.
Yeah.
I think the idea that digital stuff will be swapped out, efficiency and automation will be lost so that it can run in purely analog with lots of humans and bring everything to a crawl. I don't think that's right, but there's possibility to continue running apace with the technology, and yet for certain systems that you really don't want to lose because you can't allow anyone to touch them. You can't allow a catastrophic effect to happen to that system. I think there's ways to introduce analog technology to those things, using engineering processes that would keep the system from killing itself. I think an example would be a regulator in a car, a mechanical regulator, or do I mean governor? A governor that will keep your centrifuges from spinning too fast, or your car from going too fast. Otherwise, it's taking the input from the car just like normal until it's told to kill itself.
Right. Okay. I mean, so basically, you're talking about reference design architecture of the future, but as a whole country with vendors and DoD and DOE and EPRI and NIST and all this, I find it really, and SANS, I find it really hard to see how we bring this together in a cohesive way, where we can have a simple enough reference design to drive these products that exist in our critical infrastructure that don't have to be as complex as what we build them. The optimization scheme should be complex. The individual atomic devices themselves should not be so complicated. Sure. All right, so anyway. So I reached out to a group that we have we have a lab in Mount Holly, North Carolina, where we build a microgrid. And we also have some signage put up, and we're looking at what are new business cases we can do for smart cities. Now, we also have access to, we've been working with Navigant a lot, where we look at transportation, water treatment, traffic control, parking control. If you're in a city that has bad parking, where can you park? In buildings. And the one takeaway that in my life that I've learned about these big chunks of things are, if you want to design well before I go into this, and I'll go quickly through the slide deck, is if you can take a building and put an abstraction layer on it, and let the building be autonomous and do its own thing, and then manage it from an interface. If you're an object-oriented programmer, put an interface on it and manage that way. Same thing with water treatment. We need to come with some sort of standardization about managing a building, managing water treatment. The city's a higher level because it's got all these components, but we just willy-nilly kind of drive to solutions to solve the problem without thinking about security. So I'm lecturing to a crowd that already knows all this stuff, so I apologize for that. All right, so anyway, smart city, this is some work. So this came from a guy in our group named Jamie Cleveland. He's putting together a new sort of little business unit inside of Duke University, Duke Energy, and we're figuring out where that's going to play out. So everybody's going to be living in cities. And today 3.6 billion people are connected to the internet. Half of humanity's on the internet. So some of the things we're working on are, Duke, we own a ton of poles, and poles are a big deal, and we rent the space out on poles. There's a lot of things you can do with them. You can put cameras on them. You can put small cells. We have deals with Verizon where you can put a Verizon small cell potentially on that. You can do Wi-Fi connections. So we're figuring out how to play in the city and where these things can come into play. So at the same time, it's big business advertising, and you can put up what's going on, what events are happening in downtown Charlotte, for example, what's coming. Coming attractions, don't drive near here because it's a super crowd, kiosk, find out information about the city. So we're working on all these kinds of things, and we're tying those into the networks that we're currently building out to read meters. That's one example. We also have SCADA systems that run off cellular, basically, inside of the Duke territory, or fiber, and we can leverage those as backbone assets to reach out to these types of devices like streetlights. Well, that wasn't really streetlights. So the overall message in this portfolio, I mean, here's the list of just about everything you would want to manage inside of a smart city, from air quality on the far left to a technology on the far right, Wi-Fi. So all of these things are in play. And as we've already heard earlier, that these things need to be built with an architecture that makes sense, and they need to be built in a way that is secure. If not, every single one of those little systems there, from my view, super hackable. If you just throw it out there and stick Wi-Fi up, you've just opened up a horrible little can of worms. You just might ride down the road and all the lights are blinking, or the street lights go out of control. I think all that's fairly easy if you don't pay attention to what you're doing. It's the defense in depth piece says somebody has to really want to do this. If you put any kind of good security, I mean, if you put crypto in, well, not crypto, but let's just say authentication. Just put identity, trust, authentication type stuff with a little Diffie-Hellman in front. Do it as lightweight as you possibly can. If you do that, I think you've blocked out what percentage of the world? A ton. I don't know if you agree with that or not. But today we have none of that. And I don't see any architectures for any of this stuff. So, all right, so Duke, we're working on all these things, and we're looking for new business models to have smarter cities. Absolutely. I think that's about it. Yep, thank you.